Okay, yeah, 10. So the topic for this week is inequalities. And actually, most of you will have seen this topic before, so this is revision for the majority. Um, and I'm going to go right back to the basics, the very beginning of the topic. Some of you may find that's too straightforward because you remember it all already. If that's the case, there's no real need for you to do the first section or two. You can just skip ahead to section 3 where we begin looking at solving linear inequalities. But the easier content's there for everybody, so you can kind of review it and make sure you understand it really well. There's 4 sections to this. A quick recap of inequality notation. What do the symbols look like? What do they mean? Looking at representing inequalities on a number line. How do we draw them and what's going on there? And then into the meat of it, which is solving linear inequalities, finding answers to inequality questions. And then finally, section 4 is drawing inequalities on a graph. We often call that topic regions. So this is the section 1. One on just notation. It's very straightforward, there's nothing complicated here at all. So I'm just going to show you the information. We have 4 inequality symbols. Well, this one here, which just says greater than, and then we have this one here with the line underneath it, and that means greater than or equal to. So we can say 6 is greater than 3, and that's how we would read this information just here. We can also flip those inequality symbols around, and we can say less than instead. So I've got less than, and then also included the equal sign, less than or equal to, and we can say, for example, 4 is less than 9. An important little thing to note is less than or equal to means I can say 5 is less than or equal to 6. That's fine because 5 is less than 6. But I can also say 5 is less than or equal to 5. This is also allowed because it's equal to 5. But what I can't do is say 5 is less than 5. This is no longer true because it doesn't include the equals line, so it's not true. 5 isn't smaller than 5. So a really straightforward activity. You can have a go on your own first if you want, or you can just crack on with the video. We just need to put the right symbol in between. I'm not going to bother with the equal to symbols this time because, as you can see, none of them are equal. So is 7 bigger than or smaller than 3? 7 is bigger than 3. So I'm going to write down 7 is more than 3. Now, if you ever get muddled about which way round to draw these, I like to think of these as crocodile mouths, like this. And if the crocodile's after a meal, it's going to want to eat the bigger meal, so it's going to face towards the bigger meal. And that's true for both directions of the symbol. So if I draw it the other way around, there's my crocodile mouth, and he's going to be open towards the larger of the 2 numbers. The crocodile's always going to want to eat the bigger meal. If we look at the next one, 9 and -2, 9 is the larger one, so we're open towards the 9, and we'd read it as 9 is greater than -2, or 9 is more than -2. 2 and -1, again, 2 is the larger number here. We need to just pay attention occasionally to our number line. So I've got 2 over here and -1 over here. This way is larger. Now that's really important when we look at this 4 and -6 one. Although 6 is a larger number than 4, 4 is way over here, and -6 is way over here. 4 is much, much bigger than -6. So we draw it that way around. And the final one, -3 and 1. 1 is the larger of the numbers this time, so my symbol goes in the other direction. -3 is less than 1. It's a fairly straightforward thing to do. You just need to remember which way around the symbol needs to go. There's just one other thing that we deal with when we're dealing with inequality notation like this, and actually the key thing here is a little bit of language. So it says write down all the integers which satisfy the following inequalities. And you just need to know that this word integer means the same as whole number. So I'm looking for whole numbers that fit between 5 and 10 in this case. And you'll notice that these don't have the equals sign on them. So x is not 5. It can't be 5. It has to just be bigger than 5. Or 10. It isn't 10 because there's no equals line down here. So x can't be 5, it can't be 10. What it has to be is bigger than 5 and smaller than 10. So what numbers are bigger than 5? Well, 6 and 7 and 8 and 9. But I can't carry on because after that I get to 10 and above. So these are the only numbers that sit in between 5 and 10. Straightforward again. This time I'm between -5 and 0, and I don't have the equals lines again. So I start at -5, I've got to go up to -4, and then -3, -2, -1, and I stop because I can't include the 0. For the third one, between 3 and 7, but this time I do have my little equals line, which means I can begin at 3 now. X is allowed to be equal to 3. And then I just need to work my way up. 4, 5, 6. And can I include 7? Yes, the equals line is there, so I'm allowed to include 7. This one, I'm running from 12 to 15. Both of them have their equals line in, so I include 12 and 15. So 12, 13, 14, and 15. And then one more. I'm beginning at -2 down here. The equals line means I do include -2. Up from there is -1, and then 0, and then 1, and then 2, and then because of this equals line, I also include the 3. Nothing too complicated there, really. So your first task, your first worksheet, is popping the inequality symbol in the correct place, and then writing down this question here, really important. It just says 3 integers that satisfy, not all of them, because obviously numbers smaller than 3, actually you can go forever if you really want to. So just 3 whole numbers, and then write down all the integers for this question. And then this is a sort of exam style question. It's asking exactly the same thing, but in a slightly different way. So you should be able to tackle all of those questions now.